Hello, this is Coach Suiso, and welcome to this video going over the key for the Unit 5 multiple choice mayhem. If you are watching this for whatever reason and you have not worked through the multiple choice mayhem questions by yourself independently in 10 minutes prior to watching this video, go ahead and do that first. You will not get anything out of this if I just kind of show you the answers and you move on. Trying them, making mistakes, figuring it out, timing yourself is the big kind of component to making this something that's useful for you, especially since this test is primarily all multiple choice. Being able to do this and do the multiple choice questions well is really important. This is also one of the strongest multiple choice madnesses that I have. I think this one's fantastic. I just like that it's, I've got a little bit of everything on this, so it works really well. So let's go through it. Number 1, it says I have 150 grams of a reactant placed into a reaction vessel, and the mass of the reactant present is measured as my reaction progresses. Based on the graph below, what is the order of this reaction and what is the half-life for this reaction? So immediately upon seeing the word half-life, I know, let me look at that and just kind of see what's going on here. So if I look at my half-life, I started 150 up here. I'm going to change my color so y'all can see it. I started 150 up here. Halfway would be 75, which hits right about here at about 6. And then another half would be down here, which is at about 12, and so on and so forth. So my half-life is consistent on this graph, which means immediately I know this is going to be first order. So C and D are out. And then it gives me 2 options for the half-life. The one that obviously is the closest is 6.25. Is it exactly 6.25 based on what I saw? Who knows? It's an estimate, but it's certainly not 10. So it's going to be A. This is a 5.2 question, which is Introduction to Rate Law. All right, number 2. So first of all, we've got this intro to both questions 2 and 3, where it says the following reaction right here is performed and the reaction is found to be first order with respect to A and 0th order with respect to B. So number 2 says, if the rate of the reaction is found to be 0.25 molar per second, what is the value for K when my concentration of A is 0.1 molar and the concentration for B is 0.2 molar? So the first thing I did was I wrote out my rate law, and I just looked at what it said. It's first order with respect to A and then 0th order with respect to B, which means I don't need B in here. Because no matter what I do to B, it shouldn't affect the rate, so it shouldn't be included in the rate law. So whoop, that's out. So then I just plug in everything else. I plugged in my overall rate, I plugged in my concentration of A, and I get K to be 2.5. My units, when it's first order, is seconds negative 1. So that's a gotcha question a little bit on units, right? Make sure you know the right units. So that covers reaction rates and then overall intro to rate laws. Number 3 says that if the initial concentration of A is 0.1 molar and the initial concentration of B is 0.2 molar, calculate the concentration of B when the concentration of A has dropped to this. So this is a real 5.1 question, which is, remember, is the difference. It's like that first graphing question we did for the UDO in 5.1. So A went from 0.1 to 0.08. So I went over here and did the subtraction. It went down by 0.02. Now we need to look at the difference or the relationship between A and B. And if I come up here, for every 2 B's used up, 1 A is used up. So it's a 2B to 1A relationship, 2 to 1. So that means that for B, if the A went down by 0.02, B goes down by 0.04. So I take that initial for B, subtract out the 0.04, and I get 0.160. Which is right there. You can also use an ICE table, which is what I used in the key on the UDOs for this, but the ICE table is the same work as this, so you're doing more or less the same thing. All right, number 4 says the following reaction is proposed to take place in 2 elementary steps. We have our slow step first, we have our fast step second. It says which species would be considered an intermediate and which one would be considered a catalyst. So this is a very first pass, you know how to identify this. This concept is found in all of these lessons right here. It's just a constant kind of intertwined throughout the kinetics unit. So remember, my catalyst needs to be something that was used up here, consumed, but then reproduced here, and nothing matches the bill. So I have no catalyst. That means I know it's not going to be A and B, because these are not catalysts. And so I know it's going to be C or D, so check my intermediates. I have 2 chlorines here that are produced, but then immediately used up, so that's my intermediate. So right here. I had a lot of people asking on the UDOs if you had to include the coefficient. No. You can see here's an example where it's 2 molar here, but it's just 1 there, so totally fine. Number 5, this goes back to 5.1 again, kind of going back to basics, making sure you still remember how to do this. So this says that the reaction between A and B gas is represented below. So we got this right here. If the rate of production of AB is 0.154, what is the rate for the reaction and the rate for the B? So again, back to basics. You might look at this and be like, I feel like I have to do something complicated. You really don't. Remember that on literally the first page of 5.1, that big table that we looked at with the nitric acid and the copper 2 nitrate, and we talked about the rate of each one and the rate of the reaction. That is what this is. So if my rate of my reaction is 0.14, the rate, and by rate of it, I mean the rate of production of this. Remember, that's a 2, right? So I take that rate and I divide it by the coefficient, and that will get me my rate of the reaction. And then when I get my rate of the reaction, then I'd have to bring it back up to the one I'm looking for, which is the B2, but it's 1 to 1. So they should be the same. If I was bringing it to A, I would times it by 2, whatever the case may be. So I divide this by 2 and I get 0.077. So that's the reaction rate. And then B should be the same because it's 1. So it just ends up being the same, which is C. All right, number 6 is a 5.2, which is determining those rate laws based on experimental data. So we've got our equation right here. Here's my rate of formation of C. Here's each of my individual reactants, and I need the reaction order with respect to each of them. So when I hold A constant, B is halved, and the rate of formation of C is quartered. So that is going to be second order. And then when I hold B constant at 0.1, A is times by 4, but C doesn't change the formation rate. So that is 0th order. So I just look for that one, and it is A. All right, this has an intro to 7 and 8. It says, consider a reaction that occurs in 3 elementary steps as shown below. So immediately I see this fast equilibrium step and this slow step. So I know that this is going to be a steady state approximation question. So it just says to propose the rate loss. So this is multiple choice. So if you can kind of do it without sort of thinking about it, that's okay. You can do that because it's not free response. I did show you all the work. If it was free response, of course, you would have to show all the work. So just be aware of that. So my slow step is right here. Okay, that's this step right here. And then, of course, I need to get rid of that intermediate, which is my A. So I come over here and write my fast step, and I rearranged it in terms of A. And then I plug in, and I get this once I cancel everything out. And that is C. Number 8 says, given that reaction above, why do you expect that step 2 is the slow step? And this is a question that on an FRQ could be your justification, right? Like this would be a great FRQ question to first have you do the math and show the work and get that, and then justify why. Why would that step be slow? So this is a great example for you to look at in terms of wording for justification. If I look at it, this is all about the molecularity, which is in 5.4 and 5.5, which remember is how many molecules actually have to collide. And so in this one, it's bimolecular, right? There's 2. In this one, there's 3. And this one, there's 2. So 3, I mean, that's just so many. So all 3 particles colliding simultaneously, it is way less likely than 2 particles colliding, right? Right orientation, right amount of energy. So that would make step 2 the slowest. All right. Number 9 is another 5.5, which is a collision model question. So this is just basics about collision model. So it says, determine which of the following will increase the rate of reaction for the reaction between acetic acid and chalk. So if I look at these, I just kind of went through them and determined yes or no to start with. So heating it, yes, that increases the rate. Using a lower concentration, that's like the opposite, right? Smaller volume, no, we want more of those things. Using a higher concentration, yes, and a larger piece of chalk. Remember, we're not talking about more surface area. We're just talking about a larger piece, which would not increase my surface area. So that's no. So 2 of the above, which would be the first one and the 4th one. Big thing here is just making sure, I wrote this note to myself when I was doing it, because upon first look, you think you're looking for 1 and 2 or 1 and 4, and you're not. You're just looking for how many of these are correct. So you want to make sure you read that carefully. And number 10, it's a 5.10 question, which is a multi-step reaction energy profile. So based on the graph provided, identify the number of elementary steps, the rate determining steps, and determine if the reaction is endo or exothermic. Before I even looked at all these answer choices, I just come over here and I'm just going to actually just determine it all for myself and then go back and find the one that I'm looking for. So I notice that this is exothermic, so I get rid of B and D because those are endo. I have two transition states or activation complexes, so I'm looking for one that says that. And then I need one where the first step is my slow step. So that would be A, 2 elementary steps, and the rate determining step is step 1. C isn't right because it says there's 3 elementary steps, and the rate determining step is step 2, which that's not right either. So it's A. And that's all I got. I'm going to go back up. If you have any questions, feel free to shoot me an email. Let me know. But remember, of course, please have done these yourself before you watch the key. You can always rewatch the key if you just need kind of another refresher on it. Have an enjoyable and wonderful Thanksgiving break. If you need me, just shoot me an email for any reason whatsoever. Otherwise, I will see you when we get back.